Chapter 7, we get to start today, 7.1. We're looking at decimals. I think you're going to like this lesson. This lesson's a really soft start to this particular chapter. Not true for every chapter we do, but it's a very nice one for this chapter. So let's take a look at our leading idea to begin with. Terminating decimals are numbers that come to a clear and definite end. They're complete, simple, and easy to understand. In a similar way, faith in God offers clarity and finality in a world that often feels uncertain or endless in its complexity. And if you haven't felt that this week, you haven't been in any news outlet at all. This is a mess of a week, isn't it, Ben? Oh my goodness. Just as terminating decimals give us precise values we can trust, faith provides grounding truth and assurance, something firm to hold on to in both thought and life. So let's take a look at decimals. The word decimal comes from the Latin word that means 10. So this prefix here, deci at the beginning comes from the word meaning 10. And the first thing we're going to take a look at is the language we use to describe decimals because we often don't say them right. Okay, so I want you to make two lines and then a decimal point. And then how many do I have? I think I have 6 more. We'll go with 6, even if that's not what's on my paper. And I'm going to give names to each of our placeholders. That's what these are. They should all be on the same line. They're not quite, but that's okay. So this first place, not technically the decimal side of this, is the tens place. The next place is either, you can write units or ones. That's fine, either direction. It's the units place or ones place. And then after the decimal point, we start putting the THS's on the end. So this is the tenths. And then I've got the hundredths. And then I have the thousandths. After that, I've got the 10,000ths. And then the 100,000ths. Hang on, that's not right. THS. And the next one, it's not the final one, but it's just the final one on my screen, is millionths. And it continues on indefinitely. After millions would be 10 millionths, and then 100 millions, and then you'd have billions, and then 10 billions, and then 100 billions. Like, we could go for this indefinitely. But I think this is enough for all the ones that we're going to work with, so we're going to pause there. So we're going to practice, both in class today, and then on your group work and your homework as we get to all these things, how we say these numbers properly, because we all say them wrong a lot. Okay, so we're taking a look at this first one. There's a 3, 2, and then a decimal point, and then there's 4, 2, 3, 6. Okay, everybody has that, right? So the first thing we're going to do is we're going to describe this first number, 3, 2, and then we're going to put an and where the decimal point is. So the 3, 2 at the beginning. What number is that? 32. We don't have any trouble with that one. So we start out with 32. Fantastic. The decimal point is now an and. What happens next is we have a 4, 2, 3, 6, and we're going to ignore the place values in the sense of where does this end? You know, is it the hundredths? Is it the tenths? Is it the 100,000ths? Is it? We're not talking about that first. The first thing we look at is just 4, 2, 3, 6. In other words, if you had 4, 2, 3, 6 stand alone, how would you say that? Fantastic. That's what you're going to write next. 4,236. Now, the problem with just stopping there is it doesn't tell us where that number ends. In other words, we need to know that this number that we are given is different than if I had this number. Oh, I left my 3 out, 2 out. They both have 4, 2, 3, 6 at the end. I don't need to say anything for the zeros. So if I were writing the 4236, they would both say 4,236. But they're clearly not the same number, right? So I have to designate where the value is ending. In other words, this location where the 6 is at the very end, what is that place value? Okay, so I'm going to go back over here to make sure everybody's good. So this is 1, 2, 3, 4. We're right here. This is where it ends. So it's the 10,000ths place. So we're going to designate that in our language by ending this with 10,000ths. Now, prior to us writing that down, if you had seen this number, you probably would have said something like this, 32.4236, right? That's how we talk, right? In fact, some people don't say point anymore, they say dot. That one always still sounds a little funny to my ears, but that's okay. Okay, so, but this is how we would properly say it. If you write checks, I know that's like a archaic thing to do, but if you write checks, you're supposed to actually write the words out. Now, it doesn't go this many decimals out, but it has the same idea. You're writing it out in words, okay, for somebody. We actually had a situation when I was at another university where there was a will left, and somebody had a certain amount of money they were leaving, and they actually brought this will to the math department at our university to try to figure out what number the person wrote because they put the comma in the wrong place. And they felt like by the placement of the comma, the person was really leaving them like $100,000 instead of $10,000 or something like that. Like this literally happened. That's what they were looking at, was place value. Crazy things happen, okay? So we're gonna go the other direction too. We're gonna be given words, and we're gonna write out the corresponding numeral for it. So our written word says 536 and 76 thousandths, right? That's what it says. So take a second and write down what you believe that that's describing in numbers, and then we're going to check in with each other, okay? Does everybody have something written down? Okay, check in with somebody nearby you. Just see if it matches. Do you agree? If you don't agree, talk to each other and see if you can figure out who maybe has a misconception going on. Okay, do we get matching values? That's wonderful. Let's see what we got. So now I do want you to read it improperly so that I can write it and make sure that your written part looks like it, because if I ask you to read it properly, you're just going to read the same thing that's on my screen, right? That's not helpful. Okay, so just tell me the numbers in order. Read to me exactly what you have written down, number by number. Somebody volunteer. All right, what you got, Hannah?
536.076.
Okay, is this what everybody has? Excellent, excellent. Okay. It's not a hard task, but it's definitely not something we're accustomed to doing on a regular basis. And I teach it, and I still slip up on how I say it because it's not natural to me either, okay? So, along with those words that we wrote down underneath the lines, we're also going to talk about the values in terms of numerical values, in terms of fractions, I should say, that these represent. So again, we're going to write some lines down. We're not going to write quite as many because it'll be overkill. So just do 2 of them. Let's do 3 actually, and then a decimal point. And then I want you to do 3 more. So we'll balance it out this time. Okay, so just in words, what is that first place value on the far left? What place is that? That's the hundredths place, and so it's worth 100. Right? Anything in that place value is worth 100. So if you see a 3 there, it doesn't really mean 3, it means 300, right? Okay. How about the next place? What's it worth? 10. What's the next place worth? 1. Okay, so now moving to the other side, this next place value, what's the name of it? Tenths, right? It's the name of it, the place value is the tenths place. And we call it the tenths place because its fractional value is 1/10. That's why we call it that. These things are not just made up, like they actually go together. It's kind of cool, makes it easier to remember for sure. What's the next place called? Hundredths. So what do you think it means? 1 over 100. You got it? And the last one would be 1 over 1,000. You guys are fabulous. Okay, looking good, looking good. Now, I want to make a note of something here. Your book chooses to take those values that are in these fractional pieces the way I've written them and write them with negative exponents. We're not going to do that. I don't usually deviate from the book, but I actually have this doesn't prepare you very well for where you're headed kind of situation here, where we're just not going to do that. So if you see an answer in the back of the book that's in those negative exponents and you're comparing it to yours, don't go changing it to that. I don't want it in that form. And here's why. When you put it in those negative exponents form, it loses the connection to the value. When you see something in a fractional form like 1/10, it has meaning to you. If you see something 10 to the negative 1, you've lost the meaning entirely. Do you understand what I'm saying? So I don't want us to change it into that notation, even though the book chooses to. So when we take a look at a number like this, we're going to write it in expanded form. So let me show you what I mean by expanded form. That number in the first place, what place value was that again? Hundreds place, right? There's a 1 there, but there is 100. Think of it like money. There's $100 bill. Okay? You can skip the 0 if you want. I usually choose to write them in just so that it's present and I can see it. But if you skipped it, it would be okay. The 0 is in what place value? Tens place. The 3 is in the ones place. So what we're really doing, I know I'm not finished here, but what we're really doing is we're identifying the number that's there with the value it holds for us. Right? We only have 10 numerals, 0 through 9, but their location in the place value matters. If I put a 9 in the hundreds place, I have more money than if I put the 9 in the tens place, right? Absolutely, it matters. And if we move to the other side of the decimal, I've got a 0, but what place value am I in? Tenths place, so it's 1 over 10. And then I've got a 3 in the hundreds place, so it's 1 over 100. Right, this number literally means, if you think coins and dollar bills, that you have 3 $100 bills, 0 tens, 3 ones, 0 dimes, because that's 1/10 of money, our money, and 3 pennies, right? You know that looking at the original value, but you can see that because of the place value written next to it in this form. All right, we have a visual for our numbers, and the visual connects us back into what we did in fractions as well. It's a 10 by 10 grid. So you can draw, and we'll see how it goes. I haven't used the grid to do this yet, so we're going to see. So you're going to take a big old square, and you're going to split it into 100 little boxes. 10 rows, 10 columns, and they're probably not going to look perfect, and we're all going to be okay with that, okay? Mine aren't either. Okay, there's my 10 columns, actually. Wow, that's not where I was supposed to be. Let's try that again, okay? Okay, perfect. It is not decent. I think it's decent. I think I'm going to go with that. I thought I knew my tools, but maybe I don't. I'll have to play it later. Okay, so this is our decimal square grid. I should have drawn it on the next page. On example number 4, it asks us to draw this decimal square grid and use this grid to sort of describe or to draw in the number 0.24. So I'm going to do it on this page because I can't remember how to get the thing copied and pasted unless somebody knows good notes well enough you can tell me. I have a student in my other class who could probably, but I don't remember. So this is what I'm going to do. I'm just going to use this page to do it. Feel free to do the same thing in your notes if you don't want to redraw it. So if you flip to page number 2, it says we're supposed to shade in this. So literally this means we're going to shade in 24 of the little boxes, okay? Please do not get super creative. let's shade them all in order, okay? If you shade in a random 24 boxes and I have to actually count 24 boxes, we're all going to be grumpy. Y'all know it's true. Okay, don't do that. So 24 boxes. So if I'm shading in 24 boxes, it means I'm going to shade in one row completely. That's 10 boxes. A second row completely. That's 20 boxes. And then I need 4 more in, say, row 3 or column 3, whatever you want to call these. And this would be the decimal square representation for the number 0.24 or 24 hundredths.
Does it matter which way?
Nope, doesn't matter which way. Just don't go skipping around boxes. I'll be happy enough if you're doing them sort of like all connected would be great. Okay, so let's take a look at the connection then between fractions and decimals, because some fractions have very nice decimal form and some do not. Truth? There's some decimals that they're not very nice to look at, and some look great, right? Like 0.5, yay, I like 0.5, 0.6 repeating is not very friendly to look at. So when we're looking at those two kinds of numbers, we are going to be taking a look at how we know if it's terminating. So 0.6 repeating is not terminating because it means the 6s go on forever. But 0.5 terminates, it stops. So how do we know when that happens? Well, that's what theorem 7.1 tells us. Any rational number a over b in simplest form, underline that, highlight that, star it. That's really important. In simplest form, can be written as a terminating decimal if and only if, that means this is the requirement, the prime factorization of the denominator contains only 2's and 5's. It doesn't mean it has to have 2's and 5's. It just means it's one or the other or both. If it has 2's, if it has 5's, it has 2's and 5's, then we're good to go. If it has 3's, not good to go. Okay? So let me just give you the example that I gave you as to why it doesn't work. So if I did 0.6 repeating, this is the fraction 2 over 3. That's what it is. The denominator is not 2's or 5's or both. It's got a 3 in it. So that's why it's not going to terminate. Whereas my fraction 0.5, right, 5/10, is 1 over 2. 1 over 2 terminates because its denominator is 2's or 5's or both. Okay? Now you do have to be a little bit careful because I had you circle star, whatever, the simplest form bit, right? What happens instead if you had had the number 3 over 6? Well, if you do not simplest form it, like how I turned that into a verb, if you don't do that to it, you break the 6 apart into 3 and 2, you might be led to believe this one doesn't terminate. But I hope you know that 3 over 6 is the same thing as 1 over 2, and therefore you do know it does terminate. So no factoring the denominator, no looking at the denominator pieces until you've got simplest form going on, okay? That's what this theorem is telling us. So now we're going to practice this theorem with a couple of examples. This says mentally determine. I was talking to somebody the other day. The problem with the phrase mentally determine is that I can't see inside your brain. So you're going to have to show me some of the work that's going on in there, but I have to be able to believe that whatever's going on in there, you're still able to do without actually writing it down. That's a tricky thing to sort of assess. But mentally determine means that we're going to try and see how this would work without actually dividing it. That's what it means here. It doesn't mean grab your calculator and check it out. It doesn't mean put 9 underneath the box and put the 24 on the outside and see what happens if I try to divide. That's not what you're telling me, okay? That's not mentally doing it. So if we're looking at 9 and 24, the first thing we should be doing is what the first thing was over here on this slide. We need to put it in simplest form. So we've worked for quite some time now, right? 3.5 or so weeks on fractions. What would I need to do with 9 over 24 to get it in simplest form? Yep, we're going to simplify by dividing the top and the bottom by 3, which will give me 3 over 8. Okay, everybody good with that? Once I've gotten it into this point, I will take the 8 and I will find its factorization. So how does 8 factor? 4 and 2. Actually, I'll do it down here, and then I'll go back up. And then the 4 is 2 and 2. So its factors are 3 2's, right? That's what it is. So does it fit the criteria on the previous slide? Yeah. It does. The denominator is only 2's in simplest form. So that means that this one will be terminating. And it says if it does terminate, it wants us to actually show it. Now, you're welcome if you are so inclined to go back to the original problem and use 9 and divide it by 24. I'm not going to. There's no need. It's easier, quicker, right, if I used the reduced version, which equals the original version, and do it from there instead. So I'm going to do the division with the number 3 over 8. So 3 goes underneath the division, 8 goes on the outside. Several of you, when you were doing things on your test, reversed the order of this. Please make sure that the top goes underneath and the bottom is on the outside for division, okay? So we're not going to be able to go into this, right? Like 8 does not go into 3, so we put in a decimal point. And we ask ourselves, how many times does 8 go into 30? And the decimal point comes up, by the way. How many times does 8 go into 30? 3 is correct. What's 3 times 8? 24. What's 30 minus 24? 6. Okay, well, I still don't have 0 as a remainder, so I'm going to get 0. Like when I get to the bottom and all this said and done, I have to get 0 because we know it has to stop. So now I've got 60. How many times does 8 go into 60? 7. What's 7 times 8? 56. We're almost done. What's 60 minus 56? 4. Okay, so we need to put another 0 up there. Bring it down. How many times does 8 go into 40? 5. Because what is 5 times 8? Yay, so we're done, right? So this is where we stop. The decimal representation is 375 thousandths. That's the equivalent of 3 over 8. 375 thousandths. Okay, 10 over 24. What's my first step? Divide. What am I going to divide? Okay, so we're going to reduce or simplify our fraction by dividing the top and the bottom by 2. Did everybody catch that? Okay, great. So we're going to divide top by 2 and the bottom by 2. So 10 divided by 2 is 5 and 24 divided by 2 is 12. Is that in simplest or reduced form? Yeah, that's as simple as it will get. And then I'm going to take the 12 and I'm going to factor it. So how will 12 factor? 6 and 2, or you could have written 4 and 3 if you prefer. How will the 6 factor? 3 and 2, so I'm done. So I have 2 2s and a 3. What does that tell me? It will not terminate. And how do I know? The 3 here, right? That 3 right there tells me it won't terminate. And you can check that, right? So just grab a calculator real quick, tell it 10 over 24, and you're going to see it's going to be repeating eventually. It may be quicker than others on different values, but you're going to see a repeating decimal. So there's no reason after you answer each of these questions that you can't confirm with a calculator that you thought about it correctly, right? So if at this point you had done a problem that you said it's not terminating and your calculator said it is, first check to make sure you didn't make a mistake typing in the calculator, because that happens too. But then if it did, you need to go back. You probably either didn't reduce something you should have, or maybe you reduced incorrectly. Those are possibilities. You have to check yourself. All right, next, ordering or comparing decimals. So when we compare or we order our decimals, we're going to follow these basic steps. We're going to line up the numbers by place value. We're going to look at them from left to right and find the first place where they are different. And then we're going to compare the different digits. One's bigger than the other one. All right, that's our goal. We're going to compare those different digits. So as we're taking a look at doing that, let's order these decimals. So these are really kind of long. They're kind of ugly. And doing any of the things that we just saw is a lot easier if we stack them on top of each other. Okay, it's not like you have to. So if you don't want to do it that way, I'm not going to make you, but I'm telling you it's going to be a lot easier. So I'm going to stack mine. So I'm going to rewrite the first one, 13, and then I have a decimal point 4919. And I have 13 and I have a decimal point 492. Making sure to line things up, keep them organized. If you have graph paper or grid paper, that can be helpful here. I have a 13 and then I have 49183. And then I have a 13 and I have a 48199. Okay, now they're not all the same length, right, in terms of numbers of digits. If that bothers you, feel free to put zeros as placeholders in those spots. I'm going to show it that way just because I know it does bother some people. If it doesn't bother you and you want to leave them blank, feel free to leave them blank. But I'm going to fill them in like that.
So my paper has a 9 after the 4 on the last one, and 13.4. Mine has a 9 instead of an 8. So is mine.
Okay, so I've got a typo on my screen. Where is it? Which number?
The last one.
This one?
Yeah.
Okay, so it says what?
It has a 9 instead of an 8.
So it says 49199? Okay, cool. It's just a typo. We'll get it fixed. Yep, I'll change mine. You guys keep yours. I had to redo all my slides. I know I've told you this before, but I had to redo all my slides this summer for all of this with the new book and the new technology. And so typing everything in again have created some typos. Okay, does that look right now? Thank you, Kyra. I appreciate you letting me know that. Okay, so our goal, according to this list right over here, is to read them from left to right and find the first difference. And I don't mean differences in subtraction. I mean differences in what's different, right? How are they different? So if I'm reading from left to right, the 1s and the 3s, those are great. I'm just going to draw a line through them because they all matched. The 4s are great, and so are the 9s after I fixed my typo, right? So until I get to the thousandth place, these values aren't any different than one another. Agreed? But at the thousandth place, one of them is different than the others. Which one is it? The second one, and it has a 2 there, correct? And how does that 2 compare to the values in the other thousandth place? It's bigger. So that means that this is the biggest number. And it says we're going from least to greatest, so that tells me that this is the greatest number. It's the 4th one I'm going to have. It's the biggest. Now, I don't really need to keep looking at it, right? I don't keep comparing that value to the rest because I already made a decision about it. So I'm already done with this line, and I'm going to ignore what's happening now with this problem, right? This part of the problem. I don't need to consider it. So I'm moving on to the 10,000th place, and what do you see?
One smaller.
One is smaller. Yeah. Whoa. The 8 right here is the smallest one, right? Which means, which number is this in my list of numbers? It's going to be the least, so it's going to be the first one in my list because I'm working from least to greatest. Okay, but now I'm going to draw a line through it because I get to ignore it. I've also considered that 989 column, so I'm done. So I'm down to my last column, the 100,000ths column. And what do you see? Yeah, the last one has a 9 in it. The first one has a 0 in it. So the last one is the biggest of what remains, which would make it the 3rd largest, right? And the first one that was listed here would be the 2nd in our list. So then when I write my answer down, I need to go back to the original numbers I was given, right? And I've scratched them all out and so forth, but I've got them listed above. So the first number I'm going to write is the one that has it's this one right here. This is my first one. So I've got 13, I've got a decimal point, and then 49183. That's my first one. You can put a comma if you want. I actually prefer to put a less than sign to make it very clear that it's smaller than what comes next. My second number is the first number in the list. It's the 13 and then the 4919.
When you rewrite it,
Mm-hmm.
do you want us to give it zeros?
You don't need to put them there. If you put them there, it's not wrong though. Either way is fine. Yeah, they're not really necessary. They're just a nice visual when I'm comparing things, so I like to throw them in there. The third number, it was the last one on my list, the one that I typoed on. It's the 13 and then 49199. And then our last number was the 13 and 492 thousandths. Okay, it's okay. It's a comparison game, right? And you're just doing it methodically, going piece by piece. Okay, our last example for today. You have undoubtedly, if you've been around the church at all in your life, seen this word. What is the meaning of the word tithe, and how is that related to decimals?
How much, so you can give a percentage of your money to the church or something.
Okay, it's a percentage of your money to the church. Does anyone want to add to that description?
Usually it's 10%.
Okay, usually around 10%. What did you say?
I said usually around
Usually around 10%, okay? So here's what I want to tell you right now is it's actually not usually around 10%. It actually is 10%. The word tithe comes from the tenths. It's exactly tenths. So if somebody says, I'm tithing 5%, they're not tithing 5% because inherent in the word tithe is 10%. They can be giving 5%, that's fine, but it's not a tithe. So when the Lord says to bring the full tithe into the storehouses, he's saying 10% of your increase. So back in the Bible times, we're looking at 10% of your crops typically, or 10% of your livestock, those kinds of things. So it means literally 1/10 of something. And in terms of decimals, that's the decimal with a decimal point and then a 1. It's a 1 in the tenths place. So in practice, it works like this for us. We take our income, and let's say you got paid $300. 1/10 of that, and we'll talk more about decimals and so forth in this fashion later, means moving the decimal point 1 to the left, like so. Whoops. And $30, 1/10, is the tithe. Okay, that is the tithe by definition. But sometimes we use the word a little bit loosely, which is why it didn't surprise me for you guys to say it's about, because that is sort of an idea that we think about sometimes, you know. All right, any questions on that? All right.